NMR spectra. So the first thing you are going to want to do is find the NMR center. We have shown you all where this is before, and hopefully you have all obtained a Duoprox Cougar card. It'll have a black strip so that you can open the special door. So you'll just need to put your card up close to the door, which will flash green, and then you can head on in. The first thing you should do when you are sitting down at the NMR spectrometer is remove any metal objects that you may have on your person, such as your Cougar card and your cell phone should be set on the desk so that you do not bring them too close to the instrument within this yellow line. The next thing that I like to do is check the command box to make sure that the temperature is at 25 degrees and that none of the red lights are blinking. If the temperature is not at 25 degrees or the lights are blinking and this bar down here does not say idle, that means that somebody else left their experiment running. So I would double check that you are down here at the right time, and if you are, you should go alert somebody that somebody else's experiment is overlapping with your time, or the instrument is experiencing some problems. If the temperature is at 25 degrees and the lights are all green and stable, the next thing to do is log in to the instrument. So usually you will find it on walkup, but for this class we will be using Chem 410. So you'll find the user Chem 410 and there is no password. So you click OK and it will bring you to experiment 1. So you can see the last experiment that was done was a phosphorus. So we will like to change our experiments to proton and bring our window to sample info. This is the first set of parameters that we will change. In this class, all of the experiments will be done in chloroform. However, there is a long list of possible solvents that this NMR is capable of running. Today, we will select chloroform, and get ready to insert our sample. So the sample I have brought with me, I brought in a secondary container, as you do not just want to walk around with an open NMR tube. You'll take the sample and carefully place it into one of the spinners. There may be some resistance, but do not push enough to break these glass tubes, as you can hurt yourself or spill compound all over the spinner. Once you have your sample in the spinner, you'll need to gauge how deep the sample goes. So we place this in the gauge and push down so that our solvent is within these dashed lines and no deeper than the bottom of this gauge. Once you have your NMR tube depth measured, you can prepare to put it inside the instrument. There is always an NMR sample inside of the instrument to maintain the lock and keep it ready for future experiments. So you do not want to walk up and just set your NMR sample inside of the instrument. You first need to eject the sample that is already in there. So you can do this by pressing the eject button here, or by typing E and hitting enter in the command strip. You'll then hear the air pressure eject the sample that was already in the instrument and see it floating on top of the air pressure. You want to carefully lift up to remove the sample. If you lift sideways, you can break the sample inside of the NMR, and you do not want to do that. So you want to set your sample so that it floats lightly on the air, and carefully walk down the stairs to insert it. We can set the standard sample here in the block so we don't knock it over. To insert your sample, you can hit I, or you can hit the insert button, or you can type I and hit enter into the command line, and you can hear the air pressure stop and the sample go down the chamber, and it will click when it is seated in the instrument and ready for it to go. So now that our sample is in the instrument and we have selected our solvent, the next thing we will do is lock onto the solvent inside of our sample. So we have filled out the sample info, and now we will proceed down to lock. And you'll see it says not regulated, so the instrument is not ready to continue. To find the lock signal, you can hit the Z0, find Z0 button, and the instrument will start an experiment, and you can see that by the blue line. When the Z0 experiment is finished, you'll see the lock number jump up, and then the lock status will read regulated. If your sample, after hitting the Find Z0 button, the lock number is very low, like around 10 or 20, or very sporadic, as in it jumps all over the place, the lock status will remain unregulated. You can try to find the lock manually by unchecking lock, showing the lock scan, and using this slider to make the lock scan look like it is shown here. However, more often than not, if the Find Z0 button cannot regulate the lock status, it means your sample is either too concentrated or not concentrated enough, and you should try remaking your sample. So after the lock has regulated, we can proceed to the shim tab, where we will try to optimize this number to somewhere around 70 to 80. And we can do that by playing with the Z1 and Z2 buttons. So you can see it's set to plus or minus 10 for both of these, and right and left clicking will change these numbers. Right now, left clicking is increasing the number, so I will keep left clicking until the number stops increasing. So the number seems to have stopped increasing about 71. So I'm going to see if adjusting Z2 can get that number any higher. And it seems like left clicking does. And then I can go back to Z1 and Z2, because they play off of each other until it about stalls out at 80. If you're able to get it over 80 or all the way up to 100, you can lower this power and gain 1 or 2 and then keep adjusting Z1 and 2, because the power and gain will bring this number back down, and you can bring it back up with Z1 and 2 to get even better shims. But this seems to be as good as this sample is going to give me for now. So once you have a regulated lock at a high number between 70 and 80, you have chosen your sample, and our experiment says proton, so we know we are going to be running the right one. It's time to set up our experiment parameters. So if you go to the Acquire tab, and then under Default, we can see here the spectral width is the window size. The standard is -2 to 14. For organic compounds, that is adequate. But if you're looking for metal hydrides or other organometallic compounds, you might need to increase this window. For my research, I tend to run everything at -20 to 20 unless I know beforehand that what I'm looking for can come outside of that window. You don't want to increase your window too wide, because the wider your window, the longer your spectra is going to take, because you have to scan over a wider range. But -20 to 20 has worked for me. Other parameters that we see here is number of scans. So this is going to run 8 scans before we get to see it. That is a standard proton experiment that is okay to run. However, I like to have more control over when I get to see and stop my spectra. So the way I control the experiment is with a couple of commands. So if you type NT equals any large number, so let's start off with 200 into the command bar and hit enter, we can see that 8 changed to 200. And what that means is the proton experiment is going to go 200 scans before it stops. Now that's going to take quite a long time, but if you will also type in BS for block size equals 2, which is a really low number, that means we can pull it up and look at it after every 2 scans. And this will let me manually stop it whenever I think the experiment is done. So instead of waiting 3 minutes for the experiment to finish, I can wait however long the spectra actually needs. Either shorter if I made a really good sample, or longer if it's something that's not very concentrated. So once you have all of the experiment parameters set and auto gain checked, so auto gain is going to make sure that the signal detected by the detector isn't going to swamp out or be too strong for the detector. So if you have under default your parameters set and auto gain checked, the next thing to do is to run the experiment. So you can hit the go button, or I like to type GA for get acquisition and hit enter. And then you can see down here in the strip it says auto gain. So that was doing the auto gain function. And now that this time has started, the experiment has started. And this time, so it would take about 9 minutes for the full 200 scans to run. But now that it over here says BS2 or BS3 completed, I can look at it already. So the way that you look at your experiment is by typing WFT for wave Fourier transform and space APH. And APH is a baseline correction. Then you hit enter. This button right here, I hope you can see it, zooms everything out so you get to see the whole proton spectra. And then I'm using the mouse wheel to scroll up, and you can see the peaks of the spectra. And it's a good thing I adjusted my spectral width, because I am getting peaks outside of the standard -2 to 14. So this is the manganese ACAC sample that Tanner made in the video for experiment 3. So you can click your mouse right and left click to adjust these red lines, and then press the zoom in button to zoom in and look at your spectra while it's running. And the nice thing is we can look at it and determine if it's good, or if we need to go back and re-shim while it's running, so you don't have to stop it and restart it and waste a bunch of time. And I know it's a pretty good spectra because of these nice sharp peaks that are symmetric, and they aren't tailing off. Usually if you have really bad shims, you'll see a lot of peaks that go up and then just tail off in a non-Gaussian way. But this looks pretty good. And then we're already up at about 28 block scans, or block sizes done. And this spectra is looking pretty clear. I don't think it has to run very much longer, so we definitely did not have to wait the full 8 minutes. And what I'm doing is pressing the up arrow on the keyboard to pull up the last thing I typed into the command line and hitting enter, just so it refreshes the spectra that I get to see on the computer, so I can see the most up-to-date NMR spectrum. So I don't think this has to run any longer, so I'm going to type AA for abort acquisition and hit enter. And then you can tell that it stopped because this is now idle, and this says experiment 1 acquisition aborted. So this has stopped the experiment, but it has not saved it. So we need to go to File, Save As, and then this file finder opens wherever it was last saved to. So you'll need to go to the Home button, which looks like a little house, and then find the folder that says Chem 410. And then you can make your own folder by right-clicking and doing New Folder. Name it your first name, so I'll do Brenna. And then double-click to get in that folder. Erase everything that's in there, and then name your spectra how you want to name it. So I like to name things with the compound, and this is Unix, so you can't name things with spaces or special characters like exclamation points or parentheses. So it's basically letters, underscore, and numbers. So I'm going to do ac underscore, this was in chloroform, so CDCl3, and then this was a proton. So I have the NMR solvent and the NMR nucleus that I was looking at. And then you can hit save, and that saves the spectra that you guys just took. So if you are going to take another spectra, the software saves all of the parameters between runs. So the number of transients and the block size would be retained. You would just have to insert your new sample and relock and reshim. Because not many people know how to use the codes that I just taught you, I always reset the instrument so that it's not retained for the next user, because I don't want to make people wait longer than they need to if they don't know how to abort the acquisition or change the number of scans. But if you're running multiple of your own samples, you don't have to change anything except for relocking and reshimming the sample. But to get the instrument ready for logging out and for the next person, I always do experiments, and if you re-click proton, that resets all of the parameters so that it's clean and ready for the next person. We always need to leave a sample in the instrument, so we'll need to put the standard back into the instrument. And we need it to be we need to make sure the standard is in the instrument. We don't ever want to just put a spinner, because the way the chamber works by air pressure, so if you put just a spinner with nothing blocking this hole, it's going to sink right down to the bottom and be very difficult to get out. So make sure that you're always putting samples in, not just spinners. And we'll leave this sample in. It's got really little writing on it that says it's in D2O. So we will eject our sample and bring the standard back. Being sure to lift all the way up. insert the standard. And you can hear it click. And then the standard is in D2O, so you want to make sure to check D2O. And then we leave the instrument locked, and right now it is not regulated. So we're going to go to the lock and hit find Z0. And then we see that it is regulated and it's high at 100, which is fine for leaving the instrument. The progress bar is idle. The temperature is 25 and none of the lights are blinking. So the instrument is ready to just be left for the next person. So you can go ahead and hit log out. Take your sample gently out of the spinner, again lifting all the way up, and set it back in whatever you brought it in. Remember to pick up all of your stuff, and then grab the electronics disinfectant and spray the mouse and keyboard area lightly with disinfectant. Grab a chem wipe and spray and sanitize any of the spinners that you used so that they are ready for the next person. And then you are good to go.